Examples of tangent and cotangent left to finish. And then you guys can have some work time. So picking up where we left off yesterday, we're ready to talk about example 3, yes?
Yeah.
Okay, what do you know?
It is a tangent
Okay.
graph.
It's a tangent graph. What's a tangent graph look like?
Decreasing. Well, no, increasing?
Officially, a tangent graph is increasing.
Cotangent is decreasing. Okay.
Cotangent is decreasing.
But its reflection is going to be decreasing.
Okay, we are going to get to the fact that there is a negative out front is a reflection, so that increasing curve is actually going to turn around and become a decreasing curve. It's going to look, we're still treating it like tangent because it's a tangent function, but it's going to look a lot like cotangent. Okay, what else do we know?
The center line is 1.
Okay, center line is 1.
And it is a flattened graph because it's less than 1.
Okay, we're going to
Flat by a factor of 3/4.
Okay. We're going to vertically flatten this graph by a factor of 3/4. What else?
Your period is over. Wait, what's the formula? Pi over b, right?
Correct?
So pi over 3.
No.
Is b not? Because you get pi over 1 times x over 3. And then no, you have to do 3 over x. Pi over.
So it's pi divided by b, but b is the coefficient of x. What is being multiplied by x? And if this is x over 3, that is going to be like a 1/3 x.
Okay, so I just put 1 pi over 3 in my head. But it's actually 3 pi. So, right, it's 3 pi.
Yeah. Yes, because we're going to do pi divided by 1/3, which is pi times the reciprocal, 3 over 1, which is 3 pi. Okay, so period of 3 pi.
Phase shift is to the right. Let me get that out of the way. And then
She doesn't know how much, but she knows we're going to the right. That's good.
pi over 2 over 1/3.
Okay, so
Which is 3 pi over 2.
okay, so phase shift is c divided by b, pi over 2 divided by 1/3, which if I multiply by the reciprocal, it becomes pi over 2 times 3 over 1, which is 3 pi over 2, and that is a positive, so it is going to be 3 pi over 2 to the right.
Mark your 1.
Okay, she's not going to let me forget. Mark your center line.
Center line. Then our period is 3 pi.
Okay. Our period is 3 pi.
But since we have a phase shift to the right, we need to go 4 pi? 5?
Well, okay.
6 pi.
Back up that thought for a moment. Our period is 3 pi, but how many periods do I ask you to draw?
2.
2.
So 2 times.
So that puts you going to
6 pi.
6 pi. Now, with that in mind, we'll be okay just to label to 6 pi.
Okay.
I know the shift is 3 pi over 2, but
You'll be fine. Just
you'll be fine. And here's the deal. When I say 2 cycles, it's going to take you to 1 cycle, and then your second cycle could be either side of that first cycle. Does that make sense? So that's why you'll be fine if we just go to 6 pi here. I mean, 6 pi is already kind of big, actually, so.
Yeah.
Now, when we divide up our 6 pi, first of all, 6 pi is both periods, so we want to
Split in half. Yeah.
split it in half, and which is going to be
3 pi.
3 pi. Now, at that point, 0 to 3 pi represents a cycle, and
3 to 6.
3 to 6 pi represents a cycle. What do I ask you guys to do with each cycle always?
Cut in half.
Cut it in half, right? Sine and cosine, I say cut it in
Fourths.
fourths. But tangent and cotangent, I just say cut it in half. So what do we need here?
3 pi over 2. Yeah. 9 pi over 2. Do we have to label those?
Okay. I'm going to encourage us to on this one. It's going to be helpful. because we haven't talked about that phase shift yet.
So it'd be like
Okay,
pi
so
over 2.
those mid-marks, what's the middle? So 0 to 3. Forget the pi. What's the middle of 0 and 3?
3 pi over 2.
Okay, and I would even just say decimals here if you want. But you can think 3 over 2, or the middle of 0 to 3 is 1.5, right? But then what's 1.5 improper? And that is 3/2, right? So 3 pi over 2. Over here, what's the middle of 3 and 6?
5, 4, it's like 3, 6,
Okay.
9.
So, okay, oh, I see what you're doing. I was going to say the middle of 3 and 6 is 4.5.
Okay.
And 4.5, when you make it improper, is 9/2. I see what Delaney was doing. You made them all into halves, didn't you?
Yeah, because if you see it goes 3 over 2, and then it would go to get 3 pi, you'd get 6 over 2, and so there's like 3, 6, 9.
Yeah. So if we make these, if you had made this 3 pi 6 over 2, and this is 12 over 2, 3, 6, 9, and 12. So, yeah, I see what you're doing. And again, there's lots of different ways you can count this and figure this out.
When
so.
you say make it improper, and then what is that like?
So, like, for instance, this one was 4.5. How do we make 4.5 improper?
Oh, multiplying that. Okay.
Right.
And then keep your denominators. Got it.
Like, that's what I'm saying there. Because here's what I know is some of you, when I say what's the middle of 3 and 6, you can come up with 4.5. But to say what's the middle of 3 and 6 and you come up with 9/2 is more of a stretch sometimes.
Yeah.
Which is why I say, okay, just think 4.5. That's fine. But then make it improper. Okay. Now, what function are we graphing?
Tangent.
We are graphing tangent. I don't care about that yet.
Okay.
Yet.
Yeah.
Tangent. Tangent says we start with what?
Origin. Or no. Asymptote.
What at the origin is the key.
So 0.
So if you go back to the beginning, what's tangent say?
0. Or I draw dot at the origin.
Tangent is a dot at the origin, whereas cotangent is the asymptote. That's something you have to know.
Right.
Okay? So tangent, which is the function I'm graphing, tangent is a dot at the origin. So I'm not writing it yet, but I'm thinking, okay, here's a dot. Now, I don't write all the extra pieces here because it just gets too confusing. So where is this going to shift?
3 pi over 2.
So we're going to shift 3 pi over 2. And the dot that was supposed to be at 0 is now at 3 pi over 2. Got it? Now, I need at least 2 dots, right? Because I need at least 2 cycles. So, if there's a dot at 3 pi over 2, I need a dot once every how far?
Every other. Once every.
Once every period, which is once every 3 pi. Where is 3 pi past 3 pi over 2?
9 pi over 2.
And that is 9 pi over 2.
Oh.
Okay.
Okay. A whole 3. And then so your asymptotes would be at 3 pi
Yeah.
and 6 pi?
Because if you look here, 0 to 3 pi is 2 tick marks, yes? So if we have this broken up nicely, 2 tick marks, 3 pi over 2 to 9 pi over 2, those are my points that my curve will cross through. Where are the asymptotes?
On 3 pi.
The alternating marks, right? Yeah. So we're going to have the middle of 3 pi over 2 and 9 pi over 2 is 3 pi. You would have one at 0, and officially you would have one at 6 pi. As I said, it worked out to not draw any farther than 6 pi. Okay. Now, what am I drawing for a curve?
Starting from the left-hand quarter, going flat, and then ending in the right bottom.
Am I going up or down?
Down. Decreasing.
Okay. So tangent is traditionally increasing curve, but it's a reflected tangent, so it's going to be a decreasing the curve that looks a lot like cotangent, right?
I tried air drawing it for you, but you couldn't see it.
Well, and I looked away at the wrong time.
Yeah.
And as we cut through that origin, we're going to flatten our curve out. there is my flattened reflected tangent curve. Make it obvious to me. If I look at this, am I going to be able to say, oh, yep, this person tried to flatten their curve? Don't make me guess.
I'm going to say, yeah, I really hope. I hope.
Okay.
I'm like trying to look back at my other one, see if it's distinct enough. That one kind of looks flat, so maybe I should fix that.
I mean, you know, it's really a judgment call. And that's the thing. You don't want me to have to question the judgment, right? You want me to just be like, oh, yep, they flattened, they stretched.
Yes. And I'm going to make sure I write it too. And I need to make sure that I'm going through right at the point.
Yes, you do.
I
That's why we have the point there. Make sure you hit that point. Okay, are we ready for 4?
Yeah.
What do we know?
Cotangent, which means it decreases. And it starts in the upper left corner and ends in the bottom right.
Okay. So cotangent, decreasing curve.
Center line is -4.
Oh, by the way, make sure you have some room to go left on this graph. In other words, kind of keep your information left. You don't have to go a ton left, but I do extend my graph some on this one, the way I do it.
And it's stretched by a factor of 3.
Okay. Center line was -4. Vertical stretch by a factor of 3.
Period's pi. Go.
You guys agree with her period?
Yes.
It's pi divided by b, b being a 3. Okay.
Yeah. -2 pi.
Okay.
So to the left.
Phase shift is c over b, opposite the sign. So -2 pi over 3, and as it was already pointed out, that is going to be going left. Okay. I think we got everything there, didn't we?
Yep. Center line. -4.
Okay. Label some center line.
Make the spaces tiny.
Well, and this is where I'm just extending my graph some, because if I make the spaces too tiny, it's hard to see what I'm doing. It's hard to make it, work. Okay. Let's see. Labels. What do we need to think of?
Go out to pi over 3.
Okay.
But since you want to make it twice, you go 2 pi over 2.
Okay. So she said go out to pi over 3, but since I'm requiring 2, go out to 2 pi over 3.
And then do the opposites of -pi over 3.
And then because our shift is -2 pi over 3, we have to go left 2 pi over 3, don't we?
Yeah.
Okay, the only thing, I agree with everything she said. The only thing I would say is because I know I'm going to shift left 2 pi over 3, you wouldn't necessarily have to go right to 2 pi over 3. Does that make sense?
That's what I was thinking. I was like,
So like here, if I draw pi over 3, I'm not against you going again and drawing 2 pi over 3. But am I going to end up having to use it? Not necessarily. Does that make sense?
yes.
So nothing wrong with drawing it, but as I look at mine, I didn't draw it because then I started thinking, oh, my shift is -2 pi over 3, so I have to make sure I do that one. So I made my pi over 3, I mean, in my opinion, a decent size. You can make yours smaller if you want. But when I go left, let's make these equivalent, yes? So there's about an equivalent pi over 3, but then I need to go again, and this is why I extended mine. And I'm at -2 pi over 3.
And then do we need a tick mark between pi over 3 and the origin?
Do we need tick marks? Well,
No.
what is, I just haven't gotten there yet. So what is a period? A period is pi over 3. So there's a period. How do I want periods broken up?
Split.
Into halves, right?
Okay.
So yes, I am going to need a tick mark here.
Okay.
Because so these tick marks are either going to have asymptotes or points, 1 of the 2. Right? I don't know which yet because I haven't gotten that far yet. So that means in between each of my marks, I am putting tick marks, correct?
Yes. Shoot, I didn't leave enough room when you told me to leave room. It's
Well,
hard.
make your pieces smaller then.
It's just gonna go up. Once you hit rock bottom, now let go up.
Okay. Ready to start graphing this?
Let's do it.
What's the function I'm graphing?
Cotangent. Oh, cotangent, sorry.
cotangent, which starts with a asymptote. So, okay, so my visual, I'm not writing it down. My visual is, okay, my y-axis should be an asymptote. But
You start at pi over 3 on -2.
okay, my shift tells me to take whatever would normally be at the center, in this case an asymptote, and move it to pi over 3.
So that's going to be asymptote and the one at the center.
Okay, so, and here's the deal. How often do I need asymptotes? Once every period. So I need asymptotes once every pi over 3.
Yes.
So not every phase shift, every period. So I'm going to need an asymptote. I had an asymptote at -2 pi over 3. I need where else?
Negative pi over 3.
-pi over 3.
And 0. Axis.
And 0, the axis.
And pi over 3.
And if you want to put it on there, pi over 3. See, I just set myself up for 3 cycles, and I didn't even really try to. So easy to set ourselves up for more than 2 here. Okay. Are we okay with our placements there?
Yes.
Now, if those are the asymptotes, where are the points?
In the middle.
In the middle of those pieces, right? So point, point, point. Increasing or decreasing, and flattened or stretched.
Decreasing and stretch.
Stretch by 3.
Okay.
Dang it, Delaney. Sorry.
Okay. Cotangent is not reflected, so cotangent is just decreasing, and then it is stretched, so that means I'm going to go more vertical through the point. I'm not going to curve around and flatten out. And again, it's so easy to draw accidental extra cycles, right? So this is why I kind of knew it was coming, and this is why, Delaney, I did say that I was going to go to 2 pi over 3. Which,
It did work out, because I put the graph like that.
Uh-huh.
Did it like that.
Yeah.
So,
I mean, if I would have just had a 4th one there. Not a big deal.
but
So.
I made them bigger than these were supposed to be. So.
Mine is. I wish I could do a curve just as good. Seriously, like my last one looks.
I don't know. My morning class when I was teaching this morning, I think I redrew the same curve like 4 times
other
just
one
because I
looks-
couldn't get it. So.
Some of them look like noodles, and the other ones are just like really good.
Noodles.
Noodles, as in shaky, like not.
Chicken.
Okay, guys, you have some work time. Work on your cotangent tangent graphing worksheet, which is due Monday.
You do not have to tell me else. Especially.